for this calorimetry lab, we're going to use a hot plate, test tube holder, or crucible tongs in this case, metal sample, in a test tube, styrofoam cup, 2 thermometers, a beaker, hot hands, and a calculator. So here's what we're going to do. At the end of the lab, we'll be able to figure out, based on our calculations, which one of these metals we have in the test tube. So let's go to our list of steps, and we'll check them off as we go along. Step 1 says fill your 250 milliliter beaker with 150 milliliters of water. This doesn't have to be perfect. We're not taking the mass of this water. So just put some water in there and crank the hot plate all the way up. Make sure that it is plugged in. Okay, hot plate is plugged in. Beaker of water is on top of the hot plate. So step 1 is complete. Step 2 is complete. Obtain a metal sample in a large test tube. We did that. Remove the metal from the test tube and dump on a balance and mix. Record the mix. So here's our electronic balance. Take the metal, place it on the scale to get the mass. Make sure all of it's out. It is. And our scale reads 23.94 grams. So metal sample, step 4, we'll put this in the data table, 23.94 grams. Step 5, put the metal back in the test tube and gently place in the hot plate beaker. So we'll gently put it back on. Make sure you get all the pellets back in the test tube. And once all of the pellets, the metal pellets, are back in the test tube, we're going to put this whole thing in the beaker. So here, you want to make sure that the metal is under the water level. My metal is a little bit above the water level, so I'm going to put a little bit more water in my beaker. And I am going to let it heat up. It's important to not put the stopper on the test tube. If you put the stopper on the test tube, pressure could build up due to heating, and it could actually cause the test tube to explode. So make sure the stopper is not on the test tube. We'll put it back on the rack for you. Step 5 is complete. Step 6, get an empty, dry styrofoam cup. Find its mass. So once again, make sure this electronic balance is 0. Put the styrofoam cup on, and the styrofoam cup is 1.80 grams. 1.80 grams. Step 7 says to add 25 milliliters of tap water to the styrofoam cup. Mass the cup in the water, recorded data table. So I have 25 milliliters of tap water here. The meniscus, the bottom of the meniscus touches the 25 milliliter mark. So I'm going to put that on the scale, the electronic balance, and record the mass of both the cup and the water. So I'm getting a value of 25.62 grams. So you put that in the data table, 25.62 grams. Next step, we want to, after we check off step 6 and 7, we want to calculate the mass of the water in the styrofoam cup and record in the data table. So how we're going to do this, we are going to subtract step 7 and step 6. So use a calculator. 25.62 minus 1.80, and we get a value of 23.82 grams. Check off step 8. Determine the temperature of the boiling water on the hot plate. So right now we are going to take 2 thermometers. We're going to take one thermometer, place it in the beaker on the hot plate, and we're going to take the second thermometer and place it in the cup, the styrofoam cup with the water. I'm just going to prop it up against the test tube rack so it does not fall over. So now we're going to have to wait a little bit until the water in the beaker is boiling. I'm going to use time-lapse video to speed the video along, and I will come back when the water is boiling on the hot plate inside the beaker. As you can see, the water on the hot plate is boiling. So before we do anything, we have to take the temperature of the boiling water and the water in the styrofoam cup. So first, step 9, determine the temperature of the boiling water on the hot plate, record in the data table. So right now, our temperature is 106 degrees Celsius. So the hot plate is 106 degrees Celsius, which means the metal inside the test tube in the beaker on the hot plate is also 106 degrees Celsius. The styrofoam cup has a mass, it has a temperature of 23.5 degrees Celsius. 23.5 degrees Celsius. I'm just going to check to make sure my temperatures haven't changed. I'm still at 106, and I'm still at 23.5. So at this point, I'm going to take the test tube. Quickly, I'm going to pour the contents of the test tube into, take the test tube and pour the contents of the test tube into the styrofoam cup quickly. You want to lose heat to the surroundings, and I'm going to watch the temperature go up. I can turn the hot plate off. I am all the way up to 35 already. I'm going to stop when I've reached my highest point. I'm at 35 and a half. 36 degrees Celsius. Seems like it's stopped. Give it another minute to see if it goes up any farther. We're still at 36 degrees Celsius. And it's starting to come down. So our highest temperature was 36 degrees Celsius. 36.0 degrees Celsius. Now, let's calculate the total amount of heat absorbed by the water in the styrofoam cup. We start off by writing our formula. Q equals MC delta T. Then, we write our known and unknown values. Q is our question mark. That's what we're trying to find. M is our mass of our water. We're talking about our water for problem number 1. Our water had a mass of 23.82 grams. Our C for water is 4 4.18 joules per gram degrees Celsius. And our delta T is equal to our TF, our final temperature, minus our initial temperature, which is equal to, final temperature was 36.0 degrees Celsius, minus the initial temperature of the water, 23.5 degrees Celsius. So our final temperature of the water, 36 minus 23.5 is 12.5 degrees Celsius. Now we plug in our numbers. Q equals mass 23.82 grams times the C 4.18 joules per gram degrees Celsius times our change in temperature, which is 12.5 degrees Celsius. So we multiply these together. Grams and grams cancel out. Degrees Celsius cancel out. We're left with the unit of joules. So let's multiply all those numbers together. 23.82 times 4.81 times 12.5. We get this number. Our Q is equal to 1244.595 joules. We're going to leave this in a thin figure to the very end of the lab. Step 2 says compare the amount of heat gained by the water and the amount of heat lost by the metal. Now remember, energy cannot be created or destroyed. Law of conservation of energy, only transformed or transferred. All of the heat gained by the water was the heat that was lost by the metal. So the heat of the water, was equal to the heat lost by the metal. So these are equal. However, since the water gained heat, that means the metal had to lose heat. So the value for number 2, no calculations needed, it's the negative value of the Q for the water. So it's negative 1244.595 joules. For problem number 3, now we have to find the specific heat, the C, for the metal using Q equals MC delta T. So once again, we write our formula, Q equals MC delta T. We write our knowns and unknowns. Q equals the metal lost 1,244.595 joules of heat. The mass of the metal was the very first thing we did. That was 23.94 grams. The C is unknown. That's what we're trying to find. And our delta T, our TF minus our TI, our final temperature is 36.0 degrees Celsius. Because remember, both the water and the metal ended up with the styrofoam cup. They both ended with the same final temperature. So the temperature of the water and the metal together was 36.0 degrees Celsius. TF minus TI of the metal, the initial temperature of the metal, because the metal was originally on the hot plate in the test tube on the beaker. So it was originally 106 degrees Celsius. So if we subtract 36 minus 106, we get the delta T was negative 70 degrees Celsius. Now we plug in Q, which is negative 1244.595 joules equals the mass 23.94 grams times C we don't know times negative 70 degrees Celsius is our delta T. Next thing we do, we multiply these two values together, the mass and the delta T. So we get 23.94 times negative 70. We get negative 1244.595 joules is equal to 1 negative 1675.8, put the units together, grams times degrees Celsius, times specific heat, C. You don't want to divide both sides, you want to get C by itself, so divide both sides by negative 1675.8 grams degrees Celsius. Divide by negative 1675.8 grams degrees Celsius. So our unit is joules per gram degrees Celsius. So over here on the right side, the negative 1675.8 grams degrees Celsius, they cancel out. I'm left with C, and I'll write it over here to save room. C equals, we have negative 1,244.595 divided by negative 1,675.8. We get this long number in our calculator, and our unit is joules per gram degrees Celsius. So the long number, once again, I'm just going to write it over here for space reasons. 0.742687075 joules per gram degrees Celsius. Last step, significant figures. We look at our original numbers. We have the water, 23.82, that's 4 significant figures. 106 degrees Celsius, 3 significant figures, 3 significant figures, 3 significant figures. And of course, we have 4.18 is also 3 significant figures. So around 1, 2, 3 significant figures. The fourth number is a 6, so we round up. So our final answer, C equals 0.743 joules per gram degrees Celsius. So the specific heat of our metal, our unknown metal, is 0.743 joules per gram degrees Celsius. Now, look back on the chart on page 1 to match up the specific heat with which substance we had in our test tube.